Thank you. I want to thank you all for showing up for the Santa Barbara Real Estate Investors Association / Personal Power Project. We've got alternative energy. We're looking at rehabs today for these properties using solar, far infrared heating elements. We've got Z here handing out some information about lights, LED lights. In fact, Z just sent something to my email here recently about these curlicue light bulbs that are fluorescent that everybody's putting in their house, and I thought they were great. It shows all this ultraviolet radiation going on people that have sensitive skin, and it's really bad. It's got mercury in it. It's also got radio frequency, which gives people headaches. So basically, LED looks like the way to go, and Z's probably going to come back at a later date because he doesn't have a whole lot of time, but he'll come back for another talk and be able to get deeper into this. We're going to start off here. Anybody need to get out of here real soon? Is everybody good to go for a couple hours? No?
I'll be leaving about an hour.
Okay. Hour and a half. Okay, so a couple people have to go, but basically we're going to go for the first half hour on the infrared technology with John Whitney, and then we're going to go after that into solar with Kevin Ray. I'm basically signing up for all this stuff as a rep, so that if you guys need some help getting back to these people for information, you can contact me or them directly, whatever you choose. So at this point, I'd like to introduce John Whitney so we can hear about these far infrared heating elements.
Thank you, Dan. Appreciate it. Oh, thank you for everybody for being here. It's good to see everybody. What we're going to do, I'm going to... Oh, good. Okay. Yeah. You want to turn it off?
Yeah, just from this one.
Yeah.
Oh, okay.
We have a power surge. Okay, so
Do we have to do anything with that?
yeah, I think it's coming back up. One of the problems that we had here today, sorry, before everybody showed up, we had an actual power failure, and not just here at Denny's, it was all the buildings all the way down. And so the power is back up. You're able to get lunch. I think it's back up. Maybe it's not.
Yeah, it is.
Yeah, it is.
Yeah, it's on.
Okay, we're good. So
How long does it take for this to
it's
restart?
going to take a little bit for this to come back on, because it's not supposed to be turned off. It's supposed to cool down first, otherwise you burn out the bulb, you know. So we're probably going to have to give it a little bit of time, but we may experience some more power outages during this presentation in the next couple hours, because again, it's not just this building, it's a number of the buildings here. While John starts off, I'm going to be in the background trying to get this thing going for you.
Thanks, Dave. All right. Far infrared, let's talk about that. Far infrared, including other infrared products, have been around for a long time. Infrared, you might know, is the heat lamp in the bathroom. That doesn't work unless you stand right underneath it. Far infrared has been around for a long time. Chinese and Japanese used to use it for medicinal purposes, so it's got a health benefit to it. But with this, this is stimulated emission, and we'll go over that real quick. Basically, this is not an electric heater. I want to make that very clear. It doesn't use electricity to produce heat. What it does is uses electricity to start the stimulated emission process. Now, with this, and we can go over how it's built too, but these panels have a proprietary paste on them. And when heated up, they have certain ingredients and things attached to the paste. And as it heats up, it produces the same energy as the sun. It produces photons at a long wavelength. And again, hopefully we can show that. But the hotter it gets, the panel, as electricity is applied to the panel, it heats up the panel. The hotter the temperature at the panel produces more photons. So these things are regulated. You can regulate this to have any type of heat output you need. If you have a big room, small room, and so forth. So, and they also are hopefully this is on. Standard thermostats per room. You can have as many zones as you want, type of thing. Let's go through the PowerPoint real quick. I'm going to try to make this as quick as I can. If we can, hold off the questions until at the end, because a lot of this will probably answer your questions too. Infrared stimulated emission. This actually has changed now. The manufacturing now is in France, and of course they ship all the parts over to us, and we build them here. Let me get out of the way here. This was actually discovered in the 1970s. A French scientist was working on a project, and like everything else, it was discovered by accident, this type of technology. And he discovered that this could also be used for something else. And this is how the heating panels got started. And the name Lexan is laser expansive endothermic. That's how they came up with the name Lexan. It has now changed. That's just a brand name, and it's now changed to Future Energy Products, who actually own the company now, but it's the same technology. First distributed in Europe in 1990. They patented in 1991, and it came out to the U.S. market in 2006, and it has been here ever since. Since the 1980s, this has really evolved into a really efficient system. Stimulated emissions. No, this is really important. No coils, carbon film, or elements at all. Ceramic substrates, like some of the other far infrared units use. And again, this is another thing too. Like all electric, there's no emission. It doesn't use any fossil fuels. It doesn't create, you don't have to have a vent. It doesn't create carbon monoxide. It's as clean as you can get. And there are other benefits besides that too. We can go into that. In 2005, they finally got the UL listing for this, and that was a big chore, because when they presented this to the lab, UL Labs, they didn't know what to do with it. They've never heard of it. This was all new to them, and it took them quite a while to get UL approval or UL listing on this. And in 2005, they finally got that. It came over, if I'm not mistaken, the first part of 2000. It took them a couple of years to get approval. You know, reinventing the mousetrap. So they had no idea what to do with it. So, and then they completed it in 2006, and we're off and running. UL, Underwriters Laboratory.
Okay.
Yeah.
Thank you.
Sure. These are some of the products. Now, the normal size products, and this will show up later, 2x2, 2x4. Those are the standard size. They did it that way because they can also install them in T-bar ceilings for commercial. You can get custom sizes made. Again, this will show up later. You can have etched glass. You can take a photo and have it put on the panels. Use it as artwork. So it's pretty unique. These are the sizes. Now notice, here's 2x4, 1,000 watts. The old adage, and it's still true today: 1 kilowatt in, 1 kilowatt out. Okay, no waste. However, per kilowatt on standard electric heating is 3,416 BTUs. So this heats up 1,000 watts. Now just the plate, now I'm not talking about the paste on the plate, just the plate is 3,400 BTUs. Now this technology, you can't measure it in BTUs, British thermal units. But the heating value is 10,000 BTUs per kilowatt. That gives us a coefficient of performance up to 3.0.